Hello, everyone. Once again, Microsoft Zero to Hero, and this is Saidol. I'm so happy that I'm host another session at Microsoft Zero to Hero. And as you know, we are on our exclusive calendar in MS Build. So welcome again, whenever around the board you are. And today we are going to have another interesting topic and another great expert who is from Belgium. And it's really great to spend time, learn more about very interesting topic around AI again. So as usual, I'm going to bring my slides. So Johnny is our speaker today, and he's going to talk about building your own AI agent using Semantic Kernel. So I'm really looking forward to learn more together with you guys from Johnny about this interesting topic. So if you haven't joined us yet, aka.ms/join02hero, the short link of our learning room. So it's a great opportunity. Join us and let's learn together. As usual, we are talking about Microsoft Learn community. We are part of Microsoft Learn community, one of the biggest learning rooms in Microsoft community, Microsoft Learn community. Yesterday, we got some analytics and we realized that now we are around 5,500 members together. And it's really interesting and it's really honor to be together with you through this journey, learning journey. So about Microsoft Learn, the richest place that you can learn a lot, you can share, and you can basically get new updates, understand the new services, and also you can get connect with experts around learning rooms. And it's a great opportunity for you if you would like to share your knowledge or if you want to learn from the others. So don't miss this opportunity. aka.ms/Microsoft Learn community is the place that we can learn more about that. And if you want to know about learning rooms, aka.ms learning rooms is the short link that basically you can learn more about learning rooms. So as you know, we are in MS Build days. So if you haven't registered yet, make sure that you registered. It's a great opportunity for you to be updated and get more information about new technology, updates, and services that Microsoft is going to provide to us very soon. And basically, many topics are around AI, like today that we have this interesting topic. So make sure that you have registered 21st to 23rd. And if you are able to join to the sessions in Seattle, you are welcome. You get a lot of things around there. And if you cannot join, no problem at all. There are some sessions online that you can reach and learn more. So with that said, our code of conduct. So in Microsoft Zero to Hero community, we expected you to be aware of others, be welcoming, respectful, understanding the differences. And yeah, we are always welcome to hear from you about feedbacks, if you would like to be even in Microsoft Zero to Hero stage. So you are always welcome. So it's the time I would like to bring Johnny. Hello, Johnny. Welcome to Microsoft Zero to Hero stage.
Hello, Said. Thanks for having me.
Yeah, it's great to have experts like you in this stage. And personally, I'm really looking forward to learn more about this interesting topic from you. So thank you so much that you are in this stage today with us.
You're very welcome.
Thank you. What do you think about MS Build, Johnny? What is your favorite category in this case?
Well, as always, MS Build is a big event, a lot of information, a lot of cool things to learn, a lot of cool insights in what is coming and what is going to be new. So yeah, a favorite category. Well, I'm a real software developer, so I always look forward to seeing all things that are related to .NET development, Windows development, Microsoft development. So I'm basically interested in all of that stuff. And of course, AI is also a big component in that these days. So yeah, really looking forward to it.
Yeah, very true. Perfect. So I don't want to I don't want to wait too much with talking, and this is your stage, so we are really looking forward to learn more from you. So take over the stage, and good luck. And yeah.
All right, perfect. So yeah, I decided to do a little presentation on building your own AI agent using Semantic Kernel. And well, to be honest, a couple of months ago, when I was looking into this topic, I was overwhelmed with all of the information that Microsoft was sending to the world about AI and how AI and copilots could really help us. And as a developer myself, and I'm almost 40 years old, I've been developing for the past 20 years. Um, I'm always a little bit old school. I'm like, I like to do things just the way I did them before. I like to do things myself. So I was a little reluctant towards all of this AI stuff that's been going on this past more than a year actually. But then I decided, okay, let's be an adult about this, and let's look into what is actually on offer and how we can use and how we can leverage this. And that is how I came to know about this semantic kernel framework that Microsoft is actually building to help us use and leverage these AI opportunities into our own software, basically. And that is what I wanted to share with all of you today. Very quickly, I'm going to talk a little bit about myself, but the most important part here is that I'm going to show you a lot of code, a lot of demos, and that all of that is already available on my GitHub. So I've created a specific repository. You can see the link in the bottom. It's a bit of a long link. It's building an AI agent using semantic kernel for the Microsoft Learn Zero to Hero community in 2024. So that's the name of the repository. There's a little QR code on the screen. If you scan that, it will take you right to that repository. And I will share the same code again at the end of my presentation. Now, the reason I'm doing this is because I'm a software developer like most of you, and I really like to play around with these new things. I like to keep myself up to date. I use Microsoft Learn to learn about new technologies, and I watch YouTube videos of some people that I like, and they can explain to me what is new in very specific areas. And I like to do the same thing. So I also like to share the knowledge that I have gathered with all of you. Now, I work here in Belgium as a software consultant, and my focus is really .NET, full stack development, and Azure Cloud. I'm also a Microsoft MVP, thanks to all the things that I do for the community. And with that, I think I've said enough about me, and we can just dive into the thing we're going to talk about, which is semantic kernel. If we look at AI, and if we look at what we can do with AI, there's a couple of different steps that we can take in order to work with AI. There's a little drawing here that says on the left-hand side, there's something called a chatbot, where you can just chat back and forth with an AI chat bot, which is basically a computer program that reacts to whatever you ask, and it will give you an answer, and that's about it. So it's a pretty simple concept, which actually works pretty well with the large language models that we have created today. It really feels like you're talking to something that is almost real, but it's a simple back and forth exchange of words, basically. Never forget that a large language model has no intelligence to it. I mean, it doesn't know what you're talking about. It's just a model that statistically puts words behind each other, one next to the other. And to us, it seems like text. It seems like a reply to what we were asking, because the model itself is trained on so much data that it actually knows how to link these different words together. So it is quite powerful. It is quite cool, but it's only that. It's just a simple chatbot. If we go one level further, we can make our AI a little bit more intelligent by doing retrieval augmentation generation, which basically means that we are going to take an additional step where when we ask a question, we will actually enrich that question with some contextual data. We can use different database or vector database for that. And based on this, we will add some more context towards the large language model or the chatbot, so it can actually return to us an answer that is more correct. It's not just an invention, let's say, or it's not hallucinating. It will give us information that is actually based on the augmentation that we added, the context that we added. So it kind of knows what we are talking about and what we want from it. If we go one step further, even, we can make it a little bit even more intelligent, and we can create a copilot. And a copilot is kind of a chatbot agent that works side by side with the user to complete the specific task we're doing. So if you are a developer, you probably know about GitHub Copilot, and GitHub Copilot works side by side with you as a developer, and the task you want to complete is write code. So that Copilot has contextual information about writing code in that specific language that you are writing code in, and it also has some knowledge about the code files and the code projects and the code solutions you are working with. So you can also augment your prompt by adding it some more context, and in this way it can actually work together with you. It knows what you're doing, you know which questions you need to ask, and that also works quite well, and it's a little bit more intelligent. And then we can even go one step further, which is a fully autonomous agent, which means that when we want it to do something for us, we don't really have to do it step by step, but we can ask like a very general question, and then the copilot or the AI agent can actually respond and do very specific things in a very specific order without the need for intervention from us. So it's just like when you talk to your children or your partner, you can ask like, can you, oh, by the way, tonight when you're off work, can you visit the store? Can you get this and this and this from the store? Can you then pick up our daughter from school? Stuff like that. We just ask that question, which is kind of a big question, and everything will happen automatically, which means our partner will do that for us step by step. We can do the same thing with an AI agent. We can ask a very complex question, and then the agent will create all of the different steps that it needs to work through, and it will actually execute all of those steps without us intervening in between, which is quite powerful. And this is actually something that we can achieve with Semantic Kernel based on OpenAPI or Azure OpenAPI. Now, Semantic Kernel, as I said, is a platform, an SDK, a library that we can use in our programming language of choice. In my case, it's going to be C# and .NET to make something like that happen. And the way Semantic Kernel does that is by the use of plugins. So we can actually create plugins that sit in our software, and we can work with Semantic Kernel in combination with that plugin to actually make a copilot that is smart and knows the context of our world. And with our world, I mean the software application that we are writing. On top of those plugins, we can also use something called personas. We can actually tell the AI agent to act in a very specific way. You can ask ChatGPT also to behave in a very specific way. For example, answer like you're a 10-year-old child. This is giving a persona to that AI agent, and then it will behave in such a way. We can do the same thing with Semantic Kernel. And then finally, we can also do something like planners. When we ask a very complex question, we can create a plan, or we can have the AI create a plan for us and then work through all of those steps within that plan automatically without the need for intervention, which is quite powerful. I'm going to skip this slide, and I'm just going to show you that the Semantic Kernel today can actually be leveraged from languages as C# and .NET, Python, and also Java. So if you're working with these languages, you can actually use the Semantic Kernel package, the Semantic Kernel framework, to help you achieve those goals very easily. The supported AI endpoints, which means which models are you going to talk to. This actually supports the OpenAI models, the Azure OpenAI models, the Hugging Face models, and if you want, you can also support your custom models with a little bit of work. Now, I don't have a lot of slides prepared because I've already told you a lot of information. I just want to show you. I've prepared a lot of demos, a lot of code to actually show you what the power of Semantic Kernel is. And I'm a developer that also likes to look at demos, real demos that show the power of a framework like this. So that's what I'm going to do. So I've prepared basically 9 examples. And I'm going to run you through these 9 examples. So let's just do that and just hide those slides away. So I've created a Visual Studio solution for the first example. And maybe I need to zoom in a little bit. So give me just a moment. And I'm going to change my resolution a little bit. This is something that I needed to do beforehand, but I forgot. So let's do 150%, like that. Back to Visual Studio. And here I have created a very simple, small solution that actually uses Semantic Kernel to execute a prompt towards an AI or a large language model, that is. So this program uses the package called Microsoft.SemanticKernel. So if you look at the project properties, you can actually see that I'm using the Microsoft Semantic Kernel package version 1.13. So this is the package that will allow you to do this very easily. Now, back to my program.cs, I need to configure my semantic kernel to actually talk to my OpenAPI endpoint. So I have created an Azure OpenAPI resource on Microsoft Azure. And in this resource, I have a deployment for very specific models. And one of those models is the GPT-4 model. So I'm configuring my semantic kernel to actually use an Azure OpenAPI chat completion concept. And in order to link to that actual Azure OpenAPI resource, I'm going to provide the endpoint for that specific resource, which lives as an environment variable. And I'm going to use that private key, or just a key, to be able to access it. And again, this is just the name of the deployment for my model. So I'm using the GPT-4 model. Now, this actually looks a little bit like what you're used to in .NET. If you're, for example, used to using ASP.NET, you know that you have a web application builder or you have an application builder. You basically configure the builder, you add some dependency injection related stuff, and then finally, when you're finished, you can build your application from that builder. Now, the way we do this with Semantic Kernel is very similar. We basically create a kernel builder. We configure our kernel builder. And then when we're finished configuring, like adding this Azure OpenAPI chat completion connection, we're going to build that kernel from that builder. And now we have a kernel object that we can use to do AI stuff, to do copilot stuff. So what I can do now is I can run different kinds of prompts. So I can create, for example, a request that says, I want to know how much power my solar panels are providing. And I can put this into a prompt. So this request can be a user request. I'm going to build a prompt around that. And the prompt is going to ask the large language model or the GPT-4 model, what is the intent of the request itself? So I want to know, if somebody asks me this question, what the actual intent of that question is. And when I want to execute this prompt, I'm going to ask my kernel to invoke a prompt in an asynchronous way. In an asynchronous way because it's going to call into Azure OpenAPI. That's going to be a request over the internet. So that's going to take a little while. So I'm going to do it asynchronously. I'm going to await the result. And when it's finished, I'm going to write the result to the screen. So this is actually going to, if I run this, this is going to create an answer. If we're patient, if we're very patient. Oh, it's just the OpenAI that wants me to take a drink. Okay. So it answers me with, the intent of the request is to measure and monitor the energy output of the solar panels, possibly to access their efficiency or to calculate energy savings. So that can be a cool answer. But know that you can actually engineer your prompts in such a way to make them do something very specific. So if I go a little bit more down, I have created alternative prompts to work with the same question. So the question is always going to be the same. The request is always going to be the same. It's always going to be, I want to know how much power my solar panels are providing. But in the second example, I'm going to tell the large language model that it can only choose between something that looks like a function name, like get solar energy today, or get solar power, or get solar battery percentage, or start charging a car, for example. So if I invoke this exact same request, but now in a different kind of prompt, it's going to answer me in a different way. You probably already seen it before, but it's going to actually choose one of those function names, let's say. So this is the first one. The second one is the intent of this request is get solar power. So this is now something that I engineered in a way. I engineered the prompt in such a way that it actually answers me in that get solar power function name, which is quite cool. And to be honest, I asked for how much power are my solar panels generating right now. I did not ask how much energy they produced today. So it actually knows the difference between those two. It knows that it needs to do get solar power and not get solar energy, because those are two completely different things. Very cool. Now, of course, the large language models still answer in like a sentence. And maybe I don't want a sentence. Maybe I just want the name of that function. So I can expand on these instructions. I can, for example, say, again, what is the intent of the request? But you can only choose from get solar energy today, get solar power, and so on. And the user input is going to be the request, and the intent is going to be ... So now the large language model is just going to answer with the name of a function, for example. Again, the large language model does not know that I want to call functions or something. I'm just trying to direct it in a very specific way of answering. And you can go very far with this. Now it's just going to answer with the function name. But I can also do something like this, for example. I can tell it in like a kind of a JSON-like structure. I can say, provide the intent of the request using the following format. It needs to be JSON. You need to have a property called intent, and then you need to have the value as the actual intent. You can only choose from the following intents. Again, this is a piece of JSON, which is an array that can contain get solar energy, get solar power, get solar battery, and so on. The user input is going to be a request, and you need to answer with the intent. And if I run this again, you will actually see that based on this prompt, it will answer with a JSON object, which is quite cool. Here, this is my JSON object. This is actually Markdown syntax. So if you would show this in a UI, in a web UI, for example, it can show the Markdown format, just like ChatGPT does. But it actually tells us there is an intent property, and the value is get solar power. Again, very cool. We just changed the prompt a little bit, and because of that, we get a very specific kind of answer. And we can, again, go further with that. We can also provide examples to help the large language model to actually know in a way what it is that we want from it. By providing it examples, we are actually doing few-shot prompting. So we give it a little more context. So from that, it can derive a better solution for the request that we are actually sending. So I'm doing an example user input. How much energy did my solar panels provide today? In that way, the intent should be get solar energy today. I can do something like, can you start charging my car? And then the intent should be start charging car. So these examples will help our response to be much more reliable. Very cool. Now, why am I showing you this? I'm showing you this because the prompt itself can actually be very specific to help us to get a very good result from the things we ask the large language models. And this is actually what Semantic Kernel will also help us to do. And you will see this come back in a couple of examples further down the road. So I'm going to open the second example that I've provided for you. So let me do that very quickly. So I'm opening it in Visual Studio. Yes. So in this example, I want to show you just a regular chatbot, like you're used to when you're using OpenAI ChatGPT, for example. So again, we're using the same concept here. We're using the semantic kernel package. We're going to use the chat completion. We're going to configure it to use the Azure Open API GPT-4 deployment for the model GPT-4. And I'm going to do like an infinite loop. I'm going to do an infinite loop. I'm going to do some coloring of the console. I'm going to ask the user for a request. And then I can ask the chat completion service, which I can get from the kernel, because the kernel uses dependency injection. I can get a service from that. The iChat completion service is a service that's already configured by default within the semantic kernel package. And I can use that to get a streaming chat message content. Now, this is pretty cool. This is just like ChatGPT. When you ask a question, which is your request, it actually sends you the response as a stream. So it will stream text back to you. And you can actually live stream that text on the console. So I can do await for each to do an asynchronous for each, because the result is going to be an async enumerable. And I can show you all of those results. So you can see the result coming word for word, while the large language model is actually answering our request. Now, I can do this, but I have to do one little thing that I forgot. I'm going to need those environment variables to actually make it work. So there's a launch settings right here, and I can copy it from the previous solution. So my secret key, please don't copy. Put it here and run this chat. So if you just want a generic chatbot within your application, this is the only thing you need to do. Now I can ask my user question. So I can do, for example, who is Eddie Wally? Nobody knows who Eddie Wally is. If you're not from Belgium, this was, as you can see, a very local artist. So Eddie Wally was a Belgian singer who was known for his flamboyant style and energetic performances. So here is your standard response you would get from a GPT-4 ChatGPT. So now we can leverage this in our software by just writing a couple lines of code. Now I can add follow-up questions. I can do something like, how old was he when he died? Because he died in 2016, which is something you can already see from the answer there. And now the AI will actually tell me, sorry, but I need more information about the person in question to determine their age at the time of their death. So this is very important to know. When you send a request or a prompt to your AI model, it doesn't know a context. It's always a new question. So it's not because I asked the first question that the second question knows the context about the first question. If you want to do something like that, you basically have to send your entire history with each request you send towards your GPT model. And this is something that Semantic Kernel can also do for you. So if you already looked at my GitHub, this is actually example 3. So in example 3, I changed the code a little bit to actually keep track of all the history that I've already did with the AI model. So the basics are the same. The only thing you're doing now is I'm not going to send the request using the chat completion service. No, I'm going to create an object called chat history. And the chat history is basically an array of all the historic things that I've already asked. Now, I can add a user message to this history. So the user message is the request from the user. Now, when the chat completion service returns or streams our result in using the await for each, I'm going to add all of the content within the results to the full message. So because it's a stream of text, I'm going to keep track of a full message, a full response from the GPT-4 model. And when the await for each is finished, when the entire response is written, I have a full message, and I'm going to add it to the history as an assistant message. So you have a user and you have an assistant. So the user is your user asking the question, and your assistant is your GPT-4 model replying with a response. So now, because you add those to your history object, every time we loop through this while loop, we are increasing the history. We are adding the full context of our chat session, basically, and we're always sending the entire history towards Azure OpenAPI in this specific case. And because of that, the chat agent knows what we are talking about, and it can actually reference the things we already asked in the past. Again, I need to do the same thing to show you this. So very quickly, this is what we call not preparing your session very well. I prepared it on a different computer, and then I forgot to actually configure it to show you. So unfortunately, I really quickly need to do this every time. But now you know my Azure OpenAPI credentials, so you can go ahead and misuse my model. So I need to change this later tonight. Okay, so if I run this and I ask the exact same question, who is Eddie Wally? It's a funky name, no? Eddie Wally? He knows. We're going to get a very similar response. It was a Belgian singer, extravagant performance style and signature catchphrase. Wow. It's taking some time to finish this sentence. There we go. I think I have a slow internet connection or something. He passed away in 2016 at the age of 83. You already answered my question, but I'm still going to ask the follow-up question. How old was he when he died? And now he will know who I'm talking about, because my first question was about Eddie Wally. So now he knows Eddie Wally was born in July 12, 32, and he passed away on February 6th in 2016, which means he's 83 years old. He was 83 years old when he died. So again, very simple, a couple lines of code added to actually make the whole history work. Very cool. Now, the next step would be to introduce personas to your own chat agent. As I told you, a persona you will use to make the AI agent answer in a very specific way, or at least in a way that it looks like a kind of person. So the concept is the same. You also have the chat history, and I told you have user messages and you have assistant messages. So user messages for your users and assistant messages for the responses you get back from your AI assistant, in this case, the GPT-4 model using Azure OpenAPI. But you can also add system messages. And with a system message, you can actually direct the agent to behave in very specific way. So I'm asking it, or at least I'm adding a system message as the first historic message that states you should answer as a 10-year-old child. And this is the only thing that I've changed. The rest is the same as the previous example. So I'm adding the user message request. I'm getting I'm using the chat completion service to get the response, and I'm writing the assistant and adding the assistant's response to that historic data. Now, if I run this again, very sorry for this change. You can actually see that the way the model will respond is actually as if he's 10 years old, which is funny, I think. All right, so these two, copy, paste, and run. Who is Eddie Wally? And now he says, Eddie Wally was a singer from Belgium who was really famous for singing songs in a style called Schlager music. He was known for his flashy outfits, so it's not flamboyant because that's a kind of a difficult word. So it's flashy outfits and his big voice. So this is a way a 10-year-old basically would answer this question. And it's also more readable to a 10-year-old. So if you're making software for 10-year-olds, this is the thing you need to do to make your AI agent answer, which is pretty cool. Now, before I go to the next example, this is very, very impressive, but it doesn't really have a lot of knowledge. When you ask something, the information you get back is basically trained into the model. in this case GPT-4. So because Eddie Wally was kind of a famous person in Belgium, this information is all around the internet, and the model is trained on a lot of data that lives on the internet, but it's not real time, which means if something happens right now, the large language model will never know about that because it's not trained on the information that happens right now. It's trained somewhere in the past. So again, this feels like you're talking to a real AI agent, or like a real intelligence that knows everything, but it is not. It's just a model that puts, as I said before, one word next to the other, and to us it reads like a normal sentence, like a normal conversation, but it's just mathematics. Looks very cool, but it's not always that useful. It's fun, but it's not always that useful. Now, when Microsoft is building copilots, of course, those copilots need to be useful. You can't have just a copilot answering super random, something that doesn't really make sense. For example, if I ask ChatGPT, who is Johnny Hooyberghs, which is my name. So if I ask him, who am I? He will answer in a different way every time, and he will make things up. I've asked him that question many times because that's who I am. And he always answers with completely wrong things. He will say sometimes, yeah, Johnny is a Microsoft MVP, and then he will say he actually founded a conference named something something. I never founded a conference with that name, so it finds some information maybe that I talked on that conference in the past, but then it thinks that I was a founder of that conference, which is just not true. So you really want to avoid something like that. You only want your AI agents to return information that is correct, that is factual. And this is something where also Semantic Kernel can help you, thanks to something that is called native functions. And that is the next example that I want to show you. Let's see. So with native functions, you're actually going to enrich the knowledge of your AI agent by adding real-time information and adding that to your prompt. Of course, that is a little bit of work because you need to write those prompts as I showed you before in a very specific way so that your AI agent or your model, your large language model, actually knows enough context, enough information to give a nice answer to your user. Now, Semantic Kernel abstracts that away for you. So it actually gives you a method to define native functions that ChatGPT can actually, or that your large language model can actually call into to get factual data and then use the resulting data to actually use as a source to create the response. Now, I've created a very simple example here that has something called a general plugin. And this is what I meant before from the slides with plugins. You are basically going to write plugins within Semantic Kernel, and those plugins can be used by the large language model to actually enrich it with some factual data, factual information. So the way you do that, just the same thing as before, you configure your kernel, you connect to, in this case, Azure OpenAPI, and then you add this little line. In this little line, you're adding something called a plugin. And I've created a general plugin, and I'm going to also configure in my execution settings, so in my OpenAPI prompt execution settings, that it can actually call into my kernel functions. So in my plugin, I'm going to define functions, just C# methods, basically, that can take some arguments and that can return that, and then they can return a result. And I'm going to tell Semantic Kernel to automatically invoke those kernel functions for me when it's necessary. And then the rest of this is basically the same as before. I'm going to provide a chat history. I'm going to get the chat completion service, and I'm going to add a user message, which is the request. I'm going to use the chat completion service to get the response from that request, and I'm going to write that into the console, and I'm going to also add the full message that has been returned to me as an assistant message. So exactly the same. The only thing we changed is execution settings, auto invoke kernel functions, and adding our plugin. So what is this plugin? Let me first go back to the previous example before I show you all the magic. So when I run this one without plugins and I ask, what day is it today? The answer will be something like, I'm sorry, but I can't tell you the exact date. You should check a calendar or look at your phone. Now I feel stupid. It's actually like, are you stupid? Just check your calendar or your phone. So the large language model does not know what day it is today because it doesn't have access to real-time information. So if I go back to my native functions example and I open the general plugin, I actually defined two functions or two methods in C# called getTime and getDate. And I'm just using plain old C#. I'm using the time provider.system.getLocalNow to get the local date and time. And for this function getTime, I'm using only the time of the day. And for the getDate function, I'm only using the date and not the time. Now, these functions, you should actually add some attributes to them to actually tell Semantic Kernel that this is a kernel function and that the description for this function is get the current time. The same for the other one. It's also a kernel function and the description is get the current date. And this is actually quite magical if this is the first time that you see this working. If I go here to my native function example and I add my configuration again. Where's my mouse? Like this, and I run this, I can ask the same question and it should give me the correct answer. So what day is it today? And it will tell me, fingers crossed, today is May 23rd, 2024. This is cool. Now the AI agent really tells me what day it is because that information is now added thanks to these native functions. Now, how does this work? Well, basically, if I go back to my code, my general plugin, and I'm going to ask it for the time, for example, and I put a breakpoint here, and I ask it the same question. If I find my console, that is. So, what time is it? You can now see in the background that I hit this breakpoint. So I ask a question to my large language model. My large language model knows that I've defined some kernel functions. It knows that in order to answer my question, it needs to call one of those functions. It will tell me which function to call. I can call that function. It will hit the breakpoint. It will return the result from that function, send it back to the large language model, and then from that data, it will actually create a proper response. Very important to know, the large language model is not calling in your code. No, the large language model is actually providing an answer to that question. And in that answer, it will tell you, in order to answer this specific request, I need you to call this function with these arguments, and you can send the result back to me. And that is what Semantic Kernel automatically does for you. So you don't need to go back and forth between your large language model. You just define the functions. The Semantic Kernel package will actually create a very extensive prompt that has the original request, but it also has the context and a list of all of the kernel functions that are available with those descriptions. It will send all of that information towards the large language model. From this, the large language model can actually distill, okay, for this question, I need this function to be called. It will answer us with call this function and give me back the result from that. We send it back to the large language model, and then in this final step, it can actually work that data into a proper response, which I think is pretty powerful. Again, this is a very simple example that I've provided you. But if you are going to create a copilot for your own software, this is exactly what you need. Because when your user asks your copilot a very specific question that only is legitimate for your software or even for the window that the user is using, you can actually make it call a function in your local software that provides more information about that window or the data that is on that window, returns that to the large language model in order to then give a proper response to the user. Again, which I think is pretty amazing and pretty powerful. Now, I'm a kind of guy that really doesn't like people showing me these kinds of examples. Why am I telling you this? I always, when I go to a conference and I get like an example like this, I'm like, yeah, this looks fancy, but it's just getting the time and it's just getting the date. This is like a demo kind of thing. Well, just because I hate that, I did something for you differently. I have actually created an application that I use at home. And last week I added a copilot to it, just to show you how powerful it can be. So let me find it, this one. So this is an application that I wrote for myself a couple of weeks ago, or a couple of months ago by now. And this is actually an application that consolidates a lot of smart information about my home. It's in Dutch because I live in Belgium and I don't speak English by heart or by default. So I'm just going to translate a little bit. This consolidates information about my electricity usage. So it tells me how much power I'm consuming right now. It shows me the peak power usage that I had this month. It shows me how much energy I've used today, which means from the net, so which I bought. This is what I bought this month. Then this is my solar panels. This is I'm right now. There's a little bit of light left, so I'm actually generating 170 watts of power. This is the discharge rate of my battery at home. This is what I'm taking from the public net. All of that information is here. There's my heating. It's 24 degrees because it was a sunny day today, and my heating is off. This is the outside temperature. This is my car. How much is my car charged? It's 27 degrees inside of my car, and it has a range of 367 kilometers, and so on. And this is my sauna in the backyard. It's off. So all of that information from all of the different apps that come with all of those installations, let's say, I was sick of that. So I just consolidated everything in one single Blazor application in this case to show me all of that information in just one view. Okay, so this is quite simple to understand, I guess. Now I use this because I just open one application on my phone and I can see immediately everything, and I don't have to open all of those apps separately. Now, as I told you, I added a copilot to this last week. So if I scroll up again, I can see that there's a man thuis. Man thuis is Dutch for my home. So this is the Mine Home Copilot, and I can ask it questions. And thanks to Semantic Kernel with native function, I can actually ask it questions about real-time data in my home. So I can do something, for example, like, where is my car parked? Now it's doing exactly the same thing, and as I described before, it's sending all of those functions and the original request towards the large language model. It tells me which functions I need to call. Semantic kernel will call those functions, and it will then finally answer with a proper answer. Your car is parked at Populierenlaan in Willebroek. So now you know where I live. So this is quite cool. But because of this, you can actually do crazy stuff. I can do something like, if my car is parked in Antwerp, which is a large town not far from here, unlock my car. So now I'm actually asking a question that needs to have two kinds of information thingies. I need the location of my car, and I need to be able to unlock my car. Now, let's wait for the answer. And now the large language model answers with, your car is currently parked in Willebroek, not in Antwerp. Therefore, I won't unlock the car as per your condition. Let me know if there's anything else you need. How cool is this? So if my car would have been parked in Antwerp, it would actually unlock my car. Of course, again, the large language model will not unlock my car. It would make me call a function that will unlock my car. Let me show you the code for this. So I have a solution with all of the code for this application. So I'm going to open this. This is going to take a little longer because it's a bigger solution. I'm going to show you one more fun thing. You can have fun with this. You can do crazy things. I can ask, make a joke about the location of my car. This doesn't always work, but in most cases it works. It's not always a funny joke. Sometimes it's a funny joke. So let's see what happens. Exciting, no? Let's drink something. It's taking a long time. So I hope that is not a bad sign. Or it's hard to make jokes about the location of my cars. All right, it tells me, why don't maps bother with Populierenlaan? Because even they know your car likes to park itself there for an extended hibernation. So yeah, that's a joke about the location of my car. But in this case, I don't think it's a very funny joke. He thinks it is. But when I tried this yesterday, he had something. It was something like, my car is very popular in the Populierenlaan. Populier is the name of a tree. It's the Dutch name for a very specific tree. So he made like a little word joke. It's like a Populierenlaan, but it's a popular car, which I thought was more funny than this. Okay, but enough shenanigans. Let's show you the My Home or Mijn Thuis application. It actually has the web application for it. And in here, I've created a copilot. So I did the same thing as in the example. I've created a kernel. So this is the kernel. It's initializing the semantic kernel. It's using the chat completion service. It's going to auto invoke those kernel functions. So this is actually semantic kernel calling those functions for you automatically so that you don't need to do that manually. I'm creating a chat history. I can do some system messaging if I want, but I'm not doing that right now. I'm adding the user's request, and I'm getting the chat message response from that. Now, if you look at the functions that I can call, these are basically all the functionalities that the My Home application supports, and I put them in different plugins. So I've created a plugin for all of my car functions, a plugin for all of my heating functions, a plugin for all of my power functions, and so on. So we've played around with my car. So if I open this this class, you can see that I have a lot of kernel functions here, and I have get car location. I'm using Mediator to send a query, so I can get car overview query. This then has a property called address, and I'm returning that address. I can ask if the car is locked, but if you scroll a little bit down, I can also do things like lock car and unlock car. So the only thing I needed to do was provide all of these functions, have those attributes on top of these functions, and describe as best as you can what the function does. And if somebody asks, lock the car, the large language model will relate this to, there's a function that locks the car, so I should probably call that function. And this link will make sure that if you ask to lock the car, this function gets called. It will actually lock the car in the backend. And then the large language model will tell you something like, I successfully locked the car, depending on the return value. These functions are all quite simple. They don't have attributes, and they don't really return something in this case. But you can also, when you have, for example, an attribute or an argument, you should also add a description to that to actually explain what this argument does. And then all that information will also be sent as part of your prompt in order to make your response better. Also, if you have a return, you want to describe what the return does, you can do something like return and then the description for the specific return value, for example. I did some things with I think power, if I'm not mistaken. I do something like get power usage, then I'm going to tell it to get the current live power usage in kilowatt, so that the large language model knows that it's in kilowatt. Otherwise, it's going to use maybe it's going to to tell you that it's watts when it's kilowatts. So you need to be as specific as possible. I think there's somewhere else. Maybe it's with the solar functions. Here, get solar battery charge state. Gets the current solar battery charge state in percentage. A value of 100% is fully charged. So if you ask a question about the state in percentage, and it's 100, he will actually add that to the answer. Like the state is 100%, which means it is fully charged. So depending on what you write as a description, that will also, of course, influence the response from the large language model, which I, again, think is pretty powerful. You just need to fiddle around with it a little bit to make your responses really cool. All right, so this for me was like an aha moment. This was, for me, was like, okay, this will actually be something that I can use to make copilots that are really useful. If you can integrate this with your applications, that is just wild. That is just very, very, very cool. And I know it's almost time. There's almost 1 hour past, but I have another demo. I'm just going to show you. Let's open a browser window. Many years ago, I have created an application for my students, and I called it C# Wars. Now, this application I used to teach students how to write code in C#. And the point of the application is to, I'm going to show you the battle arena. The point of this application is to create a virtual robot that sits in this arena, and you need to make that a robot move around by writing C# code. Basically, I was sick and tired of teaching students console applications, because a console application is boring. If I want to teach a student what is an if statement, what is a variable, what is a method, what is a function, and I do it in console applications, they get bored quite easily. So I decided I'm going to create a little game, and I'm going to teach them their programming skills by basically controlling their robot. That's not an easy thing to do, but it works. And they get immediate feedback, because if you have multiple students and that they write code and they deploy their robots to this arena, they can fight each other, and they can actually see if their code is any good or not, which is fun, because you can immediately see the result of what you did. Now, with this application, you can actually play a script from scratch, which means that this is a kind of a script that you can write in C#. So I created a backend that does like the compilation of those scripts and then runs those scripts in a loop so that the robots will actually do something. And in this specific example, for each turn, it's actually going to get a step variable. It's going to load it from its internal robot memory, which is just key value. So the first time, because there is no step in memory, it's going to be 0. And then the next steps, we're going to store the increased or incremented step in memory. And then depending on the value of that step variable, if it's divisible by 3, we're going to turn left 90 degrees. And in the other two cases, we're going to walk forward, which means if I run this, or if I add this as a robot to my arena, I'm going to create a robot that walks around in squares, like 2 times forward, 90 degrees to the left, 2 times forward, 90 degrees to the left, and so on. So this is the idea. Now, when I do a demo, I have created a separate button called Play a Script from a Template. So I can actually give my robot a name, I can give it a very specific health and stamina, and then I can select from this, for example, the walk around in circles script looks like this, the walk back and forth script can look like this. If step is divisible by 5, then I'm going to turn around 180 degrees. In all other cases, I'm going to walk forward. So it's going to walk back and forth. I can also do something like look around and range attack. So I can look around. Using my vision, I can find enemy robots. And when I see the first enemy robot, I'm going to do a ranged attack towards its location. So I'm going to throw a fireball. That's the idea. Now, I was thinking about this. Okay, this code is very specific because I basically created a kind of a template with functions you can call, like move forward, turn left, turn right, turn around, range attack, self-destruct. Those are all functions that are very specific to my game. And those are the functions that you need to call. Now, with this semantic kernel, I was thinking, can I make a copilot that is smart enough to create these kinds of scripts? And I tried that. So when you go back and you play a script from scratch, where you actually need to write this code yourself, I added a little prompt window that says, write your AI prompt to generate a custom robot script. So I can do something like walk to the other side of the arena and self-destruct. Generate custom script. So I am sending this question towards my Azure Open API, and I think something failed because the text is now gone. And it will also send all of the context about my scripting game with that. And with that information, it will actually generate a script, or in this case, it doesn't. So let's try that again. Not sure what's going on. It seems that I have a little exception here, so I'm going to try something different. Let's say look around, and I'm just going to do self-destruct. Let's see. Okay, this works for some reason. So now it just knows I need to self-destruct. This is the function to self-destruct, so I can do that. Okay, let's try something else. Find the closest enemy and range attack him. Hopefully this will work. This is something that I just tried very recently, and it works in some cases. It doesn't work in other cases. But in this case, it looks like it did something. So it's actually creating a variable called closest enemy. Then it's keeping a closest distance variable, and it puts it on the maximum value. Then it's going to for each. It's going to loop through all of the enemy robots. It's going to calculate a distance based on the X and Y coordinate for itself, and then the enemy robot. And if the distance is less than the already determined closest distance, it's going to put the current enemy as the closest enemy. And it's going to put the current distance as the closest distance. Then when it's done with that loop, so when it's basically looked at all of the enemies, it now knows the closest enemy. And if that closest enemy is not null, it's going to do a ranged attack to the X and Y coordinate of that closest enemy. In the other case, it's going to turn left. So when I told him to find the closest enemy, when it doesn't find an enemy, it actually turns left 90 degrees because maybe the enemy is behind him, which I think is a pretty smart move. And then it defined an additional function or method that actually calculates the distance for my X and my Y, and then the target robot. And it uses the math square root, which is basically the Pythagoras theorem, where you basically, when you have X and Y, you want to have that that angled thingy to calculate the distance. So it's actually doing that. And I can really do my AI bot, and I can deploy this to the arena. And let's see. So it should spawn in just a moment. It's turning around, and now it's starting to throw fireballs at the closest enemy. How cool is this? This is just amazing. So with the time that I've left, I'm just very quickly going to show you the code for this so that you have an idea how that works. So let's shut this down. Also, while this is loading, maybe I need to do it like this. Just a second. Open in Visual Studio. Yes. So while this is loading, I'm going to show you one more thing. Of course, because this is a large language model and my code is in English and my description attributes are in English, but still it's a large language model, I can ask questions in whatever language. So I don't speak English at home, I speak Dutch. So I can ask kind of a question in Dutch. So I can ask, staat mijn sauna aan? Vraagteken. So staat mijn sauna aan means, is my sauna turned on? So I can ask this question in Dutch, and I should get the answer in Dutch. Now the copilot says your sauna is off at the moment. So momenteel is at the moment. So it also answers in Dutch, which again is pretty amazing. You can have people talking different languages and they still can use your copilot, because that is the power of the large language model, and the power of getting the real-time data is in Semantic Kernel. Again, while the solution is still loading a little bit, I also added this little icon, which is a speaker icon. And this actually uses your voice. So I can ask a question using this. I never tried it on this computer, so let's see what happens. What I'm going to ask. Let's see. Is my car charged at the moment? There we go. So now it says, Copilot is thinking about your question. Is my car charged at the moment? Your car is not charging at the moment. It's not really what I asked, but it's close enough. So I can also just talk to this application. It will use Azure to translate that into text, so speech to text, and it will send that towards my Copilot. And very cool what you can do these days with technology like Azure and .NET. You only need a couple lines of code and you can create all of these crazy kinds of applications. Now, this is the final thing that I wanted to show you. So the C# Wars game, how did I include the Copilot here? So I have my web application. There I have created an API controller, which has a generate script endpoint. This endpoint takes the prompt from the query string and actually uses this and uses Semantic Kernel to make that happen. In this case, I'm actually I'm not using native functions. I'm using a little bit of prompt engineering here, where I'm going to send a very extensive prompt that has the whole knowledge or as much knowledge as possible for my C# War games. So I created, when you go look at initialize semantic kernel, I actually created a file, a YAML file, where you can create a function from a prompt YAML. And I basically described my whole prompt within this YAML. So I'm getting this from my assembly resources. So it's an embedded resource in my assembly, this YAML file. I'm getting it from there, and I'm actually using it as a function in my plugin, Semantic Kernel plugin system. And if I open this YAML file, this is what it looks like. So the name for this function is the C# War script, and the description, what this function does is it translates the user requests into a valid C# syntax. And I'm going to system message with instructions for the large language model. So I'm going to tell it, you are an expert C# Wars player with very good C# knowledge. C# Wars is a game where you, the player, need to write C# code to direct your robot and make it win in a deathmatch arena. The C# Wars robot can move around and attack in a very specific way. And from a user's request, you will convert this request into a valid C# syntax that can be directly run in the C# Wars game. The generated C# script can only execute one single function because the script is run in multiple successions, and you can basically only do one action with each iteration. And that's what it says here. The script is run multiple times in succession, so the script needs to decide which actions to take each round. You are strictly forbidden from answering in a markdown code block, which means it needs to answer in just the code. It doesn't need to put it in markdown because I'm going to compile it. And when he puts the little markdown signs in front and behind, I can't compile it. And you are allowed to use the following built-in functions. And this is kind of a placeholder variable. So this is a list of all the existing C# Wars functions. And then I'm telling it, you are allowed to use the following built-in properties. And these are the C# Wars properties. And you know that the arena has the following dimensions, width and height. So the arena can actually be larger or smaller depending on the game. So I'm also adding that information here as a parameter. And then I'm going to give it a couple of examples. I'm going to give it an example. I create a robot that walks around in circles by doing 2 steps forward and a turn to the left. And I'm going to give it a C# script, again, from a variable parameter here. I'm going to give it a couple of those scripts. And then finally, I'm going to tell it there's going to be a user request and you need to return a C# Wars C# script. This is called a template on the handlebars layout. So back to the code. When I do add from function, it's actually defined. Now I know that this YAML file contains my prompt. And here, when I actually want to invoke it, when I want to ask the question, I'm going to invoke this C#wars script, and I'm going to provide all of those parameter variables that I've showed you. So I'm going to give it a list of all the function, a list of all the properties. I'm going to give it the arena dimensions, which I just hard-coded for now. I'm going to give it some templates so that it has some example code to start from. This is also cool because the functions and properties, I could hard code them. I could do like a whole big string that has all of those functions, but I decided to use reflection for that because my functions are defined in another project, which is actually somewhere here maybe. Yes, script globals. So here, these are all my, public methods. These are all my functions: walk forward, turn left, turn right, and they have comment and descriptions on top of them. So in my API controller, I have some helper methods, get C#wars functions, that will actually use reflection to get the type script globals, to get all of the public methods on that type. It will for each all of those methods. When that method has a custom attribute description, it will get that attribute and it will actually dynamically build that information for me. So I don't need to worry about this. I can add functions to C#wars and automatically my AI agent will know about those functions because here I'm just dynamically building those prompts from using reflection from my actual classes. So again, this is quite powerful, I think. And in this case, very, very cool example of the power you have with Semantic Kernel. I'm way over time, so I'm just going to shut up now. I'm going to go back to my slides. This is the final slide that also has the QR code to my repository. You can find the code for my home. You can find the code for C#wars. Everything is there. You can do whatever you want with that. Learn from it, hopefully. And again, thank you for your attention. And I hope you had fun and you learned something from this.
Amazing. Thank you so much, Jenny. Personally, I love sessions full of demos because really easy can get connect to all of this content that you share with us. And honestly, I will watch this session again because not only because of those cute bots that you created based on those game and connected to AI, but also all of these coding things that you explained to us regarding the semantic kernel. And there are a lot of opportunity behind that we can build a lot of different applications, and it's so cool. Thank you so much for these all things that you shared with us today.
No problem. I really love to do that. Thank you.
Amazing. Actually, we have one question and another things that I'll bring it up in the screen. But let's start with the question. We have question from Prejamek, if I'm not mistaken. And he said whether the semantic kernel has broader application compared to the LangChain.
I'm not sure what the question is. Do you, Said?
Can you see the
yeah,
screen?
I can see the question, but I'm not sure what he's asking. Do you understand it?
If Premajek, if you are in this session, still in the session, please maybe rephrase or mention about that part that you asked this question. But yeah, to be honest, I have no idea. But I was thinking maybe he's mentioning
maybe
about
maybe the idea here is like the LangChain. Maybe he means like it's C# or Python or Java. Can it also be used outside of that? Today, not really. So today basically it's a library built on a functionality that's already in Azure OpenAPI and OpenAPI. So a couple of months ago, OpenAPI introduced the concept of these functions. So you don't really need semantic kernel in order to make this happen. You can just write the prompts yourself. So the prompts itself, they will contain the information about which functions can be called in a very specific way, very specific syntax. You can find all of that information on the documentation pages for those services. and they will tell you how to build those. Semantic kernel is just a tool, a layer of abstraction that basically takes that away from you. And I mean, it helps you to do that for you, so you don't need to worry about that. So if you're doing C#, you can just create those functions, put those attributes on top, and he will translate that into that very specific syntax to actually send towards, in this case, Azure OpenAPI. So maybe that is an answer to that question, hopefully.
Yeah. So we have another question. How do you compare semantic kernel with Crew AI?
To be honest, I don't know about Crew AI, so I can't answer that question. I'm very sorry.
Okay.
I don't have any experience with Crew AI.
Prejamek, what
Very
that's
good.
what.
Very good.
Okay.
Perfect.
Yeah, he already got the answer. And there was another thing. So, middle of your demo, that you wanted to show us how you can connect AI to do data learning part regarding attacking, a small bot to each other. Someone mentioned that you had a typo, from attack. You type it attach. So this is a great best practice to understand how large language model does work. So even if you have some like typo like this, still it can understand what basically we are looking for. So do you have any idea how we can explain these things in really simple term?
Well,
How does it work?
yeah, when we as developers, when we are writing applications, it is, of course, it's very hard when we have some textual input, when a user wants to ask a question, like in a help window, when he makes one little mistake and we're just doing string comparison, it's very hard, because when he makes indeed a typo like that, our string comparison will fail, and we will probably answer like, I don't know what you're talking about. And this is the power of the large language model, because it's a language model. It knows about language, so it knows that if you make a typo, it looks like a word, very much, and it will make that like statistical decision just by itself. Of course, when you write something completely different, it would not work. But if you make typos, it's just close enough for the large language model to understand what you're talking about. And it's not because I made that mistake in only that word. The large language model sees all the words. And again, the large language model does not know that this is a sentence. The large language model just sees all of those separate words. If you make a typo in every word, then it's going to become more difficult, because then the whole the combination of all of those words are going to be much complexer for the large language model to make a link in between, because it does not find those words within the whole model. But because it's only one of those words where you made the typo, it has still a lot of context about that, and it will make a very close prediction on what it is that you actually want. So yeah, that is, again, it's the combination of both. It's combining the large language model with the real-time data with semantic kernel, or native functions if you're not using semantic kernel. Those two together are just very, very powerful, I think.
Yeah, it's really amazing. And for those that they want to learn more about how large language model does work, so I suggest you to check our YouTube channel. We had 4 different sessions about AI 900 in AI Skills Challenge weeks. So it's available there, and we talked about large language model and how does it work in this kind of situation. If you have typo, and how does it work, how to it act. So yeah, that's great. We have another comment. So it says, why semantic kernel C# implementation differs to the Python one, and I know the reason behind it.
Yeah, very good question. I'm also not sure. Again, to be honest, I only looked into semantic kernel a couple of, I think, a little more than a month ago. So I've been doing C# since it exists from 2001. So that is a little bit of my language. I did not yet try to look into the Python one. Maybe it's just because it's a different part of the team or different people that are working on this, that it works a little bit different. I'm not sure. I'm sorry, I can't answer that question, unfortunately.
Yeah, okay. And one more. Are we going to see hosted semantic kernel like we used to load compile assemblies into SQL Server? Maybe do something similar with Cloud kernel and add prompt or native skills to it. Think of Lambda functions.
Yeah, maybe not. I'm not sure. In any case, the semantic kernel is a package that's in this case for C#, and it's so easy to use and to implement. You can basically use it wherever you want. In this case, I used it in my console applications for demos, but I also very easily integrated it into my web applications or in my web APIs. If you want to make that into a separate server or like a hosted service, that would just work fine. Also, when you have those native functions, that native function can call whatever it wants. That native function itself can just be an HTTP request to some other service and get the information from there, return it, and then return it to the large language model. So yeah, the flexibility is almost endless there. So yeah, you can host it wherever you want.
Yeah, amazing. Thank you for the answer. So basically, we have a rule in Microsoft Zero to Hero. So we give out a voucher for the exam for the best question. So we normally ask speakers to choose which one was the best question. So then we will contact to that audience and get some information, and we will share the vouchers for the exam with them. So which question was the best?
Well, let's say the first question then. So the question that I said I didn't understand, but then I did.
This one, right?
Yes, that one. Yeah.
Okay, Przemek. Okay, perfect. Przemek, I hope I spell your name correctly. If not, so I apologize. But we will contact you. So we will share the exam voucher with you. And I hope very soon you pass the Microsoft exam. Perfect. End of the session. Thank you so much again, Johnny. It was really great. And we will share this information, and also this video immediately will be available in our YouTube channel, and also you can watch it on LinkedIn again. Beside that, 25th Saturday, we are going to have another session around the AI topic. Don't miss that one as well, and hope to see Johnny again in our stage very soon.
All right. It's been a pleasure. Thank you.
Okay, amazing. Have a good one, everyone, and see you soon in the other session on Saturday. Have a good one. Bye.